Assalamualaikum. My name is Nomirza Mansara binti Mak Farid. My matric number is 2024581265. Today I want to present for Building Technology 2 for question 1. Question 1 divided to question part 1 and question part 2. This is question 1 for part 1. The question is explain vertical load and lateral load as a type of load imposed on the frame and structure of a building. Before I answer the question 1 part 1, I will give a definition of vertical load and lateral load. Definition of vertical load is vertical load, gravity load are those forces that are applied perpendicular to the roof or floor system. These are separated into two categories such as dead load and live load. Next is definition of lateral load. Lateral load are lifts that are applied parallel to ground, that is, they are horizontal force acting on a structure. These include wind, seismic and earth load. Lateral load on a building are usually resisted by wall and bracing. This is answer question 1 for part 1. The question is explain vertical load and lateral load as a type of load imposed on the frame and structure of a building. There are two types of force which have agreed on the structure of a building: vertical load, which are primarily due to gravity, and lateral load, which occur due to wind or earthquake. Among vertical load are dead load and live load. Dead load concern the weight of such material as floor, roof and wall, while live load concern the force resulting from movable objects, including but not limited to furniture and even people occupying the space. Structure will also incur vertical pressure from snow and wind that causes uplift. Vertical and lateral load are interrelated in the sense that they will change the overall height of the structure while sustaining vertical fall. The forces are interconnected. For example, wind and earthquake, where wind causes lateral force while the load are a combination of all horizontal force. An integral element of any structure incorporating shear wall, column and bracing system act as the spine of a building, providing it with stability and security against upward pressure due to gravity and horizontal pressure caused by high wind and earthquake. This is a question 1 for part 2, differentiated beam, column and girder. Before I answer the question 1 for part 2, I will give definition of beam, column and girder. Definition of beam is: in building construction, a beam is horizontal member spanning an opening and carrying a load that may be a brick or stone wall above the opening, in which case the beam is often called a lintel. Next is definition of column. Column is the vertical structure, transmit compressive load and support the floor, and column on the bottom floor must be large enough to support the weight of each floor above. Next is definition of girder. A girder is basically a horizontal beam that support other small beam. A girder load carrying capacity will be much higher than that of other beams. Girder can be made from materials such as concrete and stainless steel, or can be combination of both. This is answer question 1 for part 2. The question is differentiated beam, column and girder. I have 8 features of beam, column and girder. First is function. Function of beam is to support horizontal load and resist bending. Function of column is to support verified load and resist compression. Function of girder is to support heavy load, often transferring them to column or support. Next is orientation. Orientation for beam is horizontal or slope. Orientation for column is vertical. Orientation for girder is horizontal or slope. Next is primary stress. Primary stress for beam is bending that is due to applied load. Primary stress for column is compression that is axial load. Primary stress for girder is bending and shear that is transfer load across span. Next is support type. support type for beam is usually supported at both and or between point. Support type for column is raised on the foundation or base, supporting overhead load. Support type for girder is typically supported by column, wall, or other beam. Next is material. Material of beam is wood, steel, and concrete. Material of column is concrete, steel, and masonry. Material of girder is steel, concrete, and reinforced concrete. Next is location. Location of beam is typically found in floor, ceiling, or bridge. Location of column is found in vertical support structure like wall, floor, or foundation. Location of girder is found in large structure, especially bridge or as primary support beam in building. Next is shape. Shape of beam is rectangular, I-beam, T-beam. Shape of column is circular, rectangular, and square. Shape of girder is I-shape, box shape, and T-shape. Last but not least is example. Example of beam is floor, beam, and roof beam. Example of column is structural column and support column in building. Example for girder is main beam in bridge, primary beam in building frame. That's all for me, and I will pass to the Shaniza to answer question 4. Thank you.
Assalamualaikum and good morning. My name is Nur Shaniza binti Muhammad Fauzi. My student ID 2024-961. Today, I want to present about the difference of damp-proof membrane DPM and damp-proof cause DPC for floor. My presentation today for my lecturer SR Dr. Hafizah Ismail. A damp-proof membrane DPM and a damp-proof gauze DPC are both used in construction to prevent moisture ingress, but they serve different purposes and are applied in different ways. So, we can go through one by one for different of DPM and DPC for floor. Firstly, a damp-proof membrane DPM. A DPM is a continuous sheet or layer of material usually made from polyethylene or similar waterproof materials. Its main goal is to prevent moisture from the ground from penetrating through floor and foundations. It is a barrier to water with vapor and liquid water. DPM are typically laid beneath concrete floors, in cold spaces, or underground slabs. It used in floor construction and sometimes walls, particularly in basements. Besides, a DPM is a thin, impermeable layer that is applied to the surface of a wall or floor to prevent moisture ingress. A minimum thickness of at least 1200 or 300 micrometers is recommended for DPM. This ensures sufficient strain and puncture resistance. DPM are commonly used in flooring applications such as under concrete slabs or circuit to prevent moisture from rising up from the ground. Damp-proof membranes are typically made of high-density polyethylene HDPE or polyvinyl chloride PVC. Other materials like sponge sheet membranes might be used in a specific situation. Generally, there are several types of material available, including polyethylene DPM, polypropylene DPM, PVC DPM, and bitumen-based DPM. However, the chosen DPM material should be compatible with other building material it comes in contact with, like concrete or circuit. Certain chemical incompatible materials might degrade the DPM over time. These are an example of damp-proof membrane DPM. Secondly, damp-proof gauze DPC. Damp-proof gauze. A DPC is a barrier typically made of material like plastic, bitumen, or slag that is installed horizontally in walls. Its primary function is to prevent moisture from rising up, usually installed at the base of walls. thus above ground level during the construction of a building. It is commonly found in masonry and brick walls. Besides, a DPC is a horizontal barrier installed in a wall to prevent the upward movement of moisture from the foundation or surrounding soil. It is typically a thin layer of impermeable material such as concrete, asphalt, bitumen or plastic that is embedded in the mortar course of a wall. The primary function of a DPC is to prevent dampness from rising up the wall and entering the building, which can lead to structural damage, decay, and health issues. There are many types of DPC such as lead, copper, bitumen, mastic asphalt, polythene, slates, bricks, and material for mortar. Furthermore, concrete is a DPC material. Concrete can be a very viable DPC option, particularly for low moisture environments and standard wall thickness. However, its limitations in impermeability and resistance should be considered. However, concrete is a commonly used material for DPC due to its several advantages such as reliability, strength, durability, and ease of construction. While concrete offers some resistance to moisture, it is not entirely impermeable. Over time, tiny cracks can develop, allowing moisture ingress. This is because concrete is brittle and can crack under excessive movement or stress, potentially compromising its effectiveness. Concrete can also be susceptible to degradation from salts like sulfates and chlorides commonly found inside. These are three an example of damp-proof coarse DPC. Is it necessary to use both DPM and DPC in a building? Yes, both are necessary to protect against different types of moisture penetration. In conclusion, understanding the difference between DPM and DPC membrane is essential for anyone involved in construction. While both are crucial for moisture control, they serve different functions and are used in different parts of a building. A DPM membrane is used to block moisture from floor and walls, while a DPC membrane prevents rising damp in walls. Lastly, using the right membrane in the right place, you ensure the longevity and durability of a building. Last but not least, there are different of DPM and DPC that good for using during the floor construction. That's all for me. Thank you.